So far, you have understood the collection, organization, and presentation of data. From now onwards, you will understand the measures of central tendency. So let us begin with calculating arithmetic mean in the case of ungrouped data or for an individual series. Let's begin with the first measure of central tendency, that is arithmetic mean. It is the most commonly used measure. It is defined as the sum of the values of all observations divided by the number of observations. Let us understand how arithmetic mean can be computed in individual series. In the previous unit, you have already understood the difference between individual series, discrete series, and continuous series. So one can estimate arithmetic mean in all the three series. When one talks about individual series, the data is ungrouped, whereas when one talks about discrete or continuous series, the data is grouped data. So obviously the method of calculation would be different in the series. Now let's begin with the calculation of arithmetic mean in individual series. There are three methods that are used to calculate arithmetic mean. 1, direct method, 2, shortcut method, and 3, step deviation method. To recall individual series, there are no frequencies and values of variables are listed singly. For example, marks obtained by the students. Let's have a tabular presentation. Now here the information is about daily wages of workers denoted as variable X in rupees. So this is the information for the daily wages as given. And one can find arithmetic mean in individual series by direct method first. So arithmetic mean by direct method would be X bar is sigma X by N, where X is the statistical value, sigma X is the summation of X, and N is the total number of frequency or values. Let's have a look at this example. The data of daily wages earned by 10 laborers in factory is given below. One needs to find average daily salary of the workers. The moment we say average daily salary, we need to find arithmetic mean. So let's see how do we do that. You need to just have the summation of all the values. So we get 3000 by having a summation of all these values. Number of workers are 10. So arithmetic mean would be summation of X by N, which is 3000 by 10. It is 300 rupees. So average daily salary of the workers is rupees 300. After the direct method, now let us move on to the shortcut method. This method is useful when the data values are large numbers. Let us first understand the steps involved. First step is the data needs to be arranged in ascending or descending order, and then you need to assume a mean from the data given. And there are two ways of assuming mean. One is that if the serial number is even in number, for example, there are 10 serial numbers given, then we shall use the method n by 2 to find assumed mean. But if the serial number is 11, for example, then we shall use n plus 1 by 2 to find the assumed mean. So once the assumed mean is found, then we need to calculate the deviations and then tabulate. How do we find deviations? This is x minus a, where x is the values given and a is the assumed mean. Then you need to sum up all the deviations and you get summation of deviations, and then estimate summation of deviations by n, and finally calculate arithmetic mean by applying this formula. X bar is equal to a plus summation of deviations divided by n, where a is assumed mean, sigma d is the summation of deviations, and n the number of observations. Let's have a look at the numerical example to understand these steps clearly. Now let us understand how to find arithmetic mean by shortcut method in individual series by a numerical example. The numerical example is about the daily wages of workers. So one can notice the daily wages of 10 workers are given. So the first step is to find assumed mean. Since the wages are for 10 workers, we shall find assumed mean by applying n by 2. So in that case, it would be fifth wage. So whatever is the fifth wage would be the assumed mean. So here, this is the fifth wage and this will be the assumed mean. Then we need to find the difference between the wages and the assumed mean. That is deviations. Have a look at the table. In the first case, it is x minus a. X is the values which are given to us. In the first case, it is 230. So the deviation is 230 minus 290, which is minus 60. In the second case, it is 250. So it will be 250 minus 290. We get minus 40 and so on. So till fourth serial number, we get values in negative. Then fifth serial number, assumed mean is 290 only. So 290 minus 290 would be 0. Then after that, the values are greater than 290 and we get all the deviations in positive. So by having a summation of deviations, we get the value of 300. N is 10. So we have found sigma of deviations as 300 and sigma of deviations by n would be 30. Now we can apply the formula, that is arithmetic mean or x bar is equal to a plus sigma d by n, where a is the assumed mean 290, sigma d by n we have found as 30. Answer is rupees 320. That is the average daily wage of a worker. Now let's understand another example of finding arithmetic mean by shortcut method in the individual series. This example is about wheat production in 1000 metric tons given for one state in the last 9 years. So here the number of observations is 9 and not 10, unlike the previous example. So let's see how do we do that. So you need to first arrange the data in the ascending order. This has been arranged in the ascending order. Then next, since there are 9 data points, now we need to find assumed mean by applying n plus 1 by 2, which is 9 plus 1 by 2, fifth value. So here, fifth value is 160. Then we shall follow the same procedure. You need to find the deviations. Deviations as x minus a. X is the values given and assumed mean is 160. So by finding deviations, we get in the first case 133 minus 160, which will be minus 27. In the next case, it will be minus 18. and so on. So far as fifth serial number is concerned, here assumed mean is 160. So deviation is 0. Thereafter, all the values are greater than 160. So we have deviations in positive. Then, like in the earlier case, we need to find the summation of deviations, which is minus 45 in this case. And n is 9. So the next step would be to find sigma deviations divided by n, which is minus 5, and then arithmetic mean by applying the same formula. X bar is equal to a plus sigma d by n. A is the assumed mean, which is 160. Sigma d by n we have found as minus 5. So the answer is 155. So the interpretation is that wheat production is on an average 155 metric ton in a state for the last 9 years. Now let us understand the step deviation method of finding arithmetic mean in individual series. First, let's have a look at the steps involved. So the first step would be that you need to arrange the data in ascending or descending order in a table. Then you need to find assumed mean from the given data, and finding assumed mean is just like the shortcut method. That is, if the data points are even in number, then we divide it n by 2 to get the assumed mean. But if the data points are odd in number, then we apply n plus 1 by 2 to find the assumed mean. Then you need to find the deviations from the assumed mean by applying d is equal to x minus a, where x is the values, a is the assumed mean that we find from either step 3 or step 4. Next step is the additional step, where you need to divide all the differences by a common factor and find d dash, that is deviation dash, which is d by c, that is x minus a by c. Like it is shown here in the table, just an example. 230 is the salary, assumed mean is 290. So you get deviation as minus 60, but deviation dash is minus 6, which is minus 60 divided by 10, 10 being the common factor. Then you need to find the summation of deviation dash, estimate summation of deviation dash by n, and finally apply the formula of arithmetic mean, which is x bar, which is arithmetic mean, is equal to a, which is assumed mean, plus summation of deviation dash by n. Now let us understand how can one find arithmetic mean by step deviation method in individual series. So here the information is about the daily wages of workers given as 230, 250 and so on. We need to apply step deviation method. So since these are 10 observations, so we shall find assumed mean by applying n by 2, which is 5. So assumed mean would be, in this case, 290. Then next we shall find the deviations as we have done in earlier cases. Deviations is x minus a, where x is the values of observation and assumed mean is 290. In the first case, we get deviations as minus 60, which is 230 minus 290. And then we follow the same method for all the observations. Till fourth observation, we get values in negative. Fifth observation would be 0, since the value is same as assumed mean, that is 290. Thereafter, we get all deviations in positive, and we can find summation of deviations, which is 300 in this case. And the next step, which is an additional step that we need to understand, is to find d dash. D dash is d by c, where c is the common factor. So one can find in x minus a as 40, 20, 10, 0, 10, 50, 90, 130, 150. So common factor is 10. So we shall divide each value by 10. And we get minus 4, minus 2, minus 1, and then 0, and then all positive values as 1, 5, 9, 13. And then finally we find summation of deviation dash, which is 30. And finally we find arithmetic mean by applying the formula x bar is equal to a plus summation of d dash by n into c, which is assumed mean 290, summation of deviations is 30, n is 10, number of observations, and common factor is also 10. So by solving this, we find 320. So the inference is that average daily wages of workers is rupees 320. A recap. One can find arithmetic mean by three methods: direct method, shortcut method, and step deviation method. By direct method, one needs to use the formula x bar is equal to summation of x by n, where x is the values of the observations and n the number of observations. In the shortcut method, arithmetic mean is a plus sigma d by n, where a is the assumed mean and d is deviations, which is x minus a, where x is the values of the observation and a is the assumed mean. And in step deviation method, one can apply the formula x bar is equal to a plus sigma d dash by n, where d dash is x by a divided by c, where x is the values of observation, a is assumed mean, and c is the common factor. So by applying these methods, one can easily interpret the information as given. I hope you have understood all the three methods, their steps, as well as the numerical examples. In the next video, we shall discuss another aspect of arithmetic mean. Till then, keep learning. Thank you. To learn more, visit our website and enroll in our courses to master economics and get a higher score in CBSE and CUET examination. With our current introductory offer, you can enroll in each of the courses for just rupees 999. So, seize the opportunity and join before the introductory offer expires. Like, share and subscribe to ECOSTUDYS channel. Also, drop a comment. See you in the next session for another concept. Thank you.